Hello, hello. Thanks for having me here today. Hopefully I'll do a reasonable job here. Never had to follow up a mayor before, so no pressure, and apparently there's at least 10,000 people here, I've been told. So my name, as was mentioned, is Nick Elder. I'm from Torc Robotics, Director of Strategy there. So we're going to change gears just a little bit. I think you're going to see some commonality despite the sort of different technology focus. I'm going to talk to you a little bit about autonomy and how Torc envisions autonomy and the future of autonomy, and how critical collaborating across the industry with partners really is to making a successful product in that case. So with that in mind, a little bit of background. Some of you may have heard of Torc, many of you may not have. We've really remained pretty under the radar, but in the space of autonomy, we're actually one of the older companies out there. So we've been in business for 16 years now, sort of got our foundation back during the really early days of autonomy with the Urban Challenge that DARPA put on, one of only 3 teams to successfully complete that, and sort of considered the grandfather of modern day self-driving technology. Was really stemmed from those early days. We're also one of a few companies that's actually productized things in the world of autonomy. So again, with this sort of common thread of having strong partners and collaborating, in the early days that was work with some of the early adopters in autonomy, whether that be mining and construction with partners like Caterpillar or in the defense space. And so we've got real products that are out there running autonomous missions out in the field today. Fast forward about 3 to 4 years ago, and we really saw the opportunity, both from the development of hardware as well as the algorithms, to say we think we're getting to that stage where we can see larger scale commercial deployments of autonomy. And we really felt like there was a lot of value, and I'll talk a little bit to why we felt that, in the long-haul trucking space. And so we were fortunate enough to meet and ultimately get a majority acquisition from Daimler Trucks. And so we were the first to announce that deep OEM partnership with a major Class 8 trucking OEM. And we think that's really sort of going to be one of our key foundations when we look at this ability to collaborate with the right experts to really bring together, I think a word that was used earlier, right, an ecosystem that's required to enable autonomy. So a little bit sort of about Torc's footprint, right? I mentioned we've been in business for 16 years, slowly growing, slowly supporting development with some of our partners. In that time, we've grown quite considerably. So we're still headquartered out in Virginia, but we've got areas across the globe really targeted and focused on different things, whether that's our offices in Stuttgart that have direct connection to your sort of leading tier 1 suppliers when it comes to things like hardware, as well as an office not 5 miles from here that we opened up earlier this year to really tap into the great talent that exists within the Austin area when it comes to development of algorithms. There we go. So one of the things that's been sort of a common thread of Torc from the very early days and continues to this point is a common thread in our mission. And that mission has been from day one to save lives. Now, back in the early foundation of Torc, that connection was pretty direct and obvious, right? We were working to remove warfighters from danger and harm's way. Same in the mining arena, right? This is a job that's dangerous, dirty, and if we can take a human out of a haul truck, there's sort of that direct connection to saving lives. When we look to move into this, what we believe to be a much larger space for commercial deployment with long-haul trucking, really we wanted to kind of keep that same mission alive, right? And so ultimately that boils down to several things. First and foremost, there are a large number of crashes that happen every year with large Class 8 trucks. Thousands of those that end in fatality. So there's still that direct correlation with being able to create systems that are safer and ultimately save human lives. But really that theme of saving lives goes well beyond that direct correlation. When you look at something like freight infrastructure, the ability to move goods around our country, it's reliant heavily on the use of trucking. And that goes from everything from transporting the food that we eat, the medicines that we need, the critical components for everyday life. And then last but not least, an area we've touched on many times this morning, but that constant need to reduce our carbon footprint, right, that's going to be a very multi-pronged approach. Electrification certainly is going to be a major constituent of that, but for the coming years, that long-haul leg of transport is still going to rely heavily on combustion engines. But if we can do that more efficiently, more effectively, reduce CO2 emissions, we've got yet another facet of this ability to save and better lives. So all that kind of leads us to, one of the reasons we wanted to target the area of long-haul trucking. But really, in order to deploy a useful technology, you have to have more than sort of a vision for why you want to do it. There has to be a strong business case for why that technology is actually going to proliferate. So I mentioned one of the reasons that we really wanted to target long-haul trucking is we felt like that was going to be really the first early adopter of large-scale commercial autonomy. And really the reasons boil down to, these is just 3 of them, there's many more, but again, I kind of mentioned that safety thread. Depending on what study you look at, the numbers may vary, but ultimately the vast majority of collisions with automobiles come down to human error. So if we can make that safer, reduce the number of incidents where poor human judgment has maybe caused an incident, that not only saves lives, but ultimately saves large amounts of money to carriers and fleets and shippers and ultimately to final end customers. Secondly, and these 2 are somewhat connected, but if you look today, by some estimates, there's 80,000 drivers shortage within the country, right? That means today, while goods do get moved around, ultimately carriers and trucking companies have a significant deficit in the number of drivers that are really willing to do this job, and that's particularly in the case of long-haul trucking, which I'll touch on in a moment. Those numbers are projected to increase considerably as you look towards the end of the decade, doubling in the shortage of drivers, and then in combination with that, we're shipping more and more goods all the time. So the number of goods that are being shipped by the end of the decade is expected to double as well. So that's sort of laying the groundwork for why we think it's a good idea to go into this, but I keep mentioning this term long-haul trucking. Well, what exactly does that mean? So there's plenty of examples where goods are transported short distances across the city, not necessarily a great utilization of autonomy today, but where autonomy can be very powerful, and another reason that we felt strongly in the use of long-haul trucking as a first application for autonomy is in these longer transport legs, in the hundreds and even thousands of miles between origin and destination. In this case, the first and last mile may be the more complex urban surface street operations, but ultimately the majority of the transport is on highways and interstate infrastructure that's far more predictable, far more prescribed in lane widths, geometries, rules of the road. And so ultimately what that's going to look like, if we fast forward to the days that we actually launch a commercial product in Class 8 trucking, it's really going to target that middle mile. And so what that's going to look like, right, imagine you're a carrier, you operate a large fleet of trucks. You're going to continue to have relationships with shippers that need goods moved. You're going to continue to get those freight shipments through the same systems you've used before, and you're going to have human drivers, manually operated assets, that go to wherever the location of that shipper is, connect to that freight, bring that freight to a new autonomous transfer point, right? These points can be located very near highway or interstate systems where you minimize the complexities of getting from that hub location ultimately out onto the highways and the interstates. So at this hub, you can then connect the freight to an autonomous asset, so an autonomous Cascadia. At that point, checkouts that would need to be done for the autonomous system can be done. It's also going to then connect and be communicating with sort of what we call mission control. You can imagine the air traffic control here that's overseeing the autonomous system. But when they give all the green lights that it's good to go on the mission, that vehicle's then going to leave with no human behind the wheel, right? A fully self-driving level 4 Cascadia. That trip from that location, that hub location to the interstate will be short, minimize the complexities of surface street operation, and the vast majority of that travel will be on highways and interstate systems that, again, are much more streamlined in the way that they operate, in the way that the infrastructure is laid out. Along that way, there will always be a connection back to this mission control, right? This individual behind a panel that can supervise multiple self-driving assets. Should the asset run into inclement weather, high traffic situations, perhaps have a mechanical failure, right? A blown tire. This is the person that would be interacting with that system, calling roadside assistance or taking whatever the correct course of actions are at that point. But ultimately, this level 4 truck will be transporting freight from the autonomous hub to the final destination autonomous transfer point. Once that asset arrives at the destination hub, it will again detach the load. That load will then be connected to a manually operated asset, and that final mile delivery into what could potentially be complex inner city, right? This might be finally delivering the load into the middle of Chicago or downtown Manhattan. That portion of the transport leg for the foreseeable future and likely indefinitely will need to be handled by human drivers. So when we look at this problem of a significant shortage of human drivers, really what autonomy is looking to do in the Class 8 space is not displace jobs in any way. What we're really looking to do is sort of fulfill that deficit that already exists, really targeting the portion of trucking in which drivers are least inclined to want to move into as a career choice, right? That middle mile portion of the leg where you're gone away from your family for days or weeks on end. So with that in mind, right, I've talked a little bit about kind of how we envision autonomous trucking working. I'd kind of now like to start to get into this idea of how do you collaborate? How do you build this up? The term was used earlier when we're looking at electric vehicles of the need for a comprehensive infrastructure, right? It's more than just an electric vehicle. You need charging capabilities. There are some similar parallels when you're looking at autonomy, right? There's more than one constituent here. So we've got the hardware itself, the redundant chassis that we're able to leverage our connection with Daimler to really tap into the class-leading Class 8 semi-trucks with a world-leading set of redundancy components built into that, as well as the direct ability to build in high-performance computing and sensor packages directly at the factory. Then you get to sort of this middle portion, right? This is where Torc is focusing our efforts. This is the brains, if you will, the software that allows that autonomous capable system of operating safely on the road. So this is the autonomous driving software that perceives the environment around it, decides what are the correct sequence of actions to take, and then executes those actions. But last but certainly not least is what you see here on the far right, this customer and partner engagement. So in order for autonomous semis to be useful, they not only need to be capable of safely driving down the road without a human, but we also need this capacity to service and maintain those vehicles, provide that oversight in operations that's required while these self-driving vehicles are on mission, as well as the roadside assistance to support not only the mechanical failures or typical failures you might see on a truck today, but potentially new failure modes that may exist in the future with autonomous assets. And then last but not least is this idea of the autonomous transfer hub, right? This location in which manually transported freight can be detached, reattached to an autonomous asset, and deployed without a human behind the wheel. So really, as we think about how Torc envisions this need to collaborate in order to create not only a safe product, but one that actually meets the needs of the industry and can have a positive impact on end customers, but really society as a whole, you can kind of look at three major constituents, right? One is hardware. How do we ensure that we have hardware and the ability to service that hardware in a way that's actually scalable? So I touched a little on our work with Daimler and the ability to use that powerful OEM. As we look to the sensor and the compute package that's required to enable autonomous technology, we're really tapping into those primary tier ones that have been supporting the automotive industry for years, and in some cases where new technology is required, say in long-range LiDAR sensing, we're also looking at other partners that are really building that core competency and have the strengths in those areas like Luminar. The development of self-driving technology goes well beyond the hardware as well, though, right? There's a lot of tools required to build up this system, both from a development perspective, but also from a test and validation perspective, so that we can create a genuinely safe, reliable product that's really able to, again, go out there into the market in meaningful volumes and create a meaningful impact. So with that, we've got simulation from folks like Applied Intuition, data sets from a broad host of folks like Smart Drive Analytics, all of which we can really partner with to bolster capabilities and really leverage that collaboration with strong partners. And then last but certainly not least is actually tapping into the knowledge and the understanding from the industry itself. So this is just a couple of the folks that we work with, but really it's the idea to bring in the major carriers, the major fleet servicers, and understand how are we going to deploy this technology in a way that can actually be serviced and actually be used by the industry. And then last but not least, I kind of wanted to talk again, this common thread of safety, right? How do we ensure that the system we're developing is going to be safe, that's ultimately going to produce that goal of saving lives? Commercialization is one thing, but on the road to commercialization, there's an immense amount of development and testing that has to occur. One of the things that Torc has been extremely adamant about, as well as Daimler, is this need to do that in a safe and responsible way, right? We understand that it's a privilege to be able to test our systems on public roads, and that's going to be a necessity to get this to the point that we have a deployable product. But we don't want to do that in a way that in any way risks the public or in any way jeopardizes the safety of what we're doing. And so our process for implementing new functionality, for testing new functionality on public roads is extremely exhaustive, both from a collaboration internally within safety committees, the ability to simulate any kind of functionality before we're willing to take that out on the roads, run that in closed course testing as well in the real world, and then ultimately really vet that functionality before it ever sees any sort of public road. In addition to that, we're continuously working with local municipalities where we test to ensure that they understand the work that we're doing, that we have sort of a clear and defined focus on the work that we're doing, how we do it, and how we ensure that it's done safely. And so again, that common core piece of DNA from Torc and the 16 years we've been in business really continues to be fostered in the way that we do our development today. So ultimately, what does that mean, right? It means we still have quite a ways to go. All of this comes together to lead our development activities, to make sure that the product we're developing will ultimately, again, bring value to the end customer, but also to society as a whole. But what that looks like is continued and safe testing on public roads as we are ready to do that. But more importantly, what it means is not tying ourselves to a particular date that we're going to have a product. Certainly, it's our goal to get to commercialization as soon as possible, but it will ultimately be dictated by when we have a system that is safe enough, that we've validated to a high enough level of confidence that we feel good about actually releasing that product. So when we kind of look at how we see the future of freight at Torc, again, really comes to four sort of key pillars, right? This idea of making sure that we're collaborating with partners, with the industry as a whole, so that the product we're developing will bring value to the public as a whole and to the end customers. Making sure we're leveraging the strengths of our partners, right? Where we can utilize hardware from a tier one, where we can utilize the strong foundations of an OEM, or another partner to produce a portion of the software or verification stack that we need, really helping to leverage that. And then ultimately being safe stewards of the resources we have, right? Building that trust with the public, testing in a manner that takes safety above all things, and ensuring that the way we go about our development is safe, as well as eventually the product that we deploy. And really with all that in mind, as I mentioned, what that boils down to is that while this technology is going to have a major impact and we feel completely confident that we are going to reach this goal, we still have some time ahead of us before we have a completely safe product that we're ready to deploy. And that timeline is really going to be dictated by when we can meet the levels of rigor and our criteria for creating a safe product and deploying that system out in the real world.